Okay, now before we start, just a reminder, we're working on hypothesis testing. And hypothesis testing is very much like a confidence interval. As a matter of fact, almost exactly the same thing and same process. It just comes out with a yes or no type of answer. Okay, and here's the problem with hypothesis testing. What do you guys know about sampling? What does Jamie know about sampling?
Not much.
Any kind of sampling. Is it
It's a proportion of.
true? Is it always accurate?
No.
Oh, there's something called sampling variability, right? Which means that every sample is gonna be a little different. Do you think it's possible to get a wonky one?
Yeah.
Quite possible to get a wonky one. Now, back in Math 3, we used to do this thing where you would like randomly choose like ovals. Your eyes are always drawn to the bigger one. And so we didn't do it, we didn't do it. But it's kind of a good lesson for this class almost. Maybe I'll try to bring it back to this class someday. But it's possible to get a wonky sample. Okay, and it's really kind of scary to think about the fact that you're gonna make this scientific discovery decision based off of one sample. So there's two possible errors that can be made. So does it make sense that you might get a wonky sample and it might be an error? Okay, just because samples vary, you might get a weird one. Okay, so that's how we're going to frame these two. Now, I'm going to show you the joke first because the joke is a learning joke and it's about murder. So let's just talk about some murder. Don't worry, I won't make it gross or anything. I like a little bit of true crime in my life. Okay. So here's my joke, and I'm going to talk about this for just a minute. And if you watch the movie I suggested you watch, which you probably didn't, I think it's like 3 hours. But anyways, okay, it's okay. I can boil it down for you in terms of what you need to know for today. Okay, so there's two types of errors that you can make with a hypothesis test. Type 1 and type 2. Okay, remember we're bringing this all back to court cases and the judicial system. Shawshank Redemption is a movie about a guy who was sent to prison for a double murder that he did not commit. Okay, let me say that again. Shawshank Redemption is a movie about a guy who was sent to prison for a double murder that he didn't commit. So that was a type 1 error. He was found guilty when he wasn't really guilty. Okay, now the opposite, OJ, and these past, there's some opinions about OJ, but we're pretty sure that he did this. So type 2 error is the opposite. That is being found not guilty of some double murder that we're pretty sure that he did do. So OJ Simpson found not guilty for a double murder that many years later, we pretty much figured out that he did do. Okay, do you see those two opposite errors? Okay, so this one was found guilty when he's actually not guilty. And this one was found not guilty when he's actually guilty. Okay, now let's turn that to hypothesis testing language. This one, we rejected the whole when you're supposed to fail to reject. And this one, you failed to reject the whole when you were supposed to reject. And the whole reason for us isn't about evidence and if the glove fit, you should have quit and any of that stuff. You have to watch OJ stuff for that to be alone. But anyway, it's about the sample that you got being weird. So sometimes the sample leads you to believe one way or another way, but the sample is off from the population. Okay. I have another type 1 and type 2 error joke. I think it's tomorrow, hopefully, that I think will help you guys remember. I also have a dumb Mrs. Talbot way for you to remember stuff. Okay, so type 1 error. The sample led you to believe you should reject the hoe when you should have failed to reject. Okay, and then I related that back to court case. Okay, type 2 error is the opposite. The sample led you to believe you should fail to reject when you should have rejected. I can't write. That word's supposed to be guilty. I don't know what happened to it. It got mangled. Okay. So those are the like formal definitions of those two. Now you're sitting there thinking to yourself, Mrs. Talbot's going to ask me to identify a type 1 or type 2 error, and she's going to ask me to describe it and all of this, but how do I keep it straight in my head? Well, this is how you're going to do it. You're going to say, okay, if I failed to reject, that means it's a type 2. See, I took the word to and failed to reject, and I changed it to a 2 so that you would know that that was a type 2 error. One of my dumb Mrs. Talbot things. Okay. Now we're going to relate this back to confidence intervals. We're going to find the probability. How often are we going to find someone guilty when they're actually not guilty? Or how often are we going to find statistical significance when it's not actually significant? How often do you think that's going to happen? Okay, it depends on the confidence level. Okay, so we're going to start with 90% confidence because that's really easy to kind of imagine in your mind. So imagining a 90% confidence level. If I have a 90% confidence in something, how much do I expect to be wrong? Okay, and this is an alpha of 0.10.
this is how confidence level and alpha are related. The probability of a type 1 error is equal to alpha. Okay, now the probability of a type 2 error has an inverse relationship with the probability of type 1. And we're going to talk about that more later. Okay, now we're going to talk about the 3 most popular alpha values. And we put these in our notes on Friday also. But I want to talk about criminal versus civil lawsuits. Okay, I know, weird. So, you guys know what a criminal lawsuit is? You know what a crime is?
Yeah.
Okay, so you know, well, somebody's suing someone, a lot of times it's the government or the county or the city suing someone for breaking a law of some kind. Does that make sense?
Yes.
Okay. Do you guys know what a civil lawsuit is? What does that mean?
It's like, getting money. That's good, right?
It has to do with money, exactly. Okay. The threshold for finding someone guilty in a civil lawsuit is much higher than a criminal lawsuit. Guys? Okay, I want you to think about the consequence of a type 1 error in a civil lawsuit.
You
Okay, is that gonna be a horrible, terrible thing? I mean, not really. Compared to a type 1 error in a criminal lawsuit, what would be a type 1 error in a criminal lawsuit? Sending someone to prison or the death penalty when they were innocent. Okay, so that means that the thresholds for those need to be different. And I forget the wording exactly. One of them is beyond a reasonable doubt. What's the other one? The criminal one and the civil one have different wording. I should have looked it up before you guys came. Yeah, honey.
We put part D, right?
No, it's later. Oh, they're in the bottom shelf of the little. Okay. So alpha equals 0.01 is very strict. And the probability of a type 1 error is the lowest. You want to use that when the consequences for committing a type 1 error are very big, like say the death penalty, or like say sending someone to prison for the rest of their life for something they didn't do. We have to be really, really strict about what we want to prove that. And so this is what you would use in a criminal situation. Alpha equals 0.10, on the other hand, is the least strict usually. Where the probability of type 1 isn't super terrible. But maybe the probability of type 2 would be something really, really bad. And so you'd want to use this in a least strict situation. So finding something being the same when it's actually changed, when you want to use that when this is a really bad thing. Because sometimes this is worse than this, and sometimes this is worse than this, depending on the context. Yes, exactly. Okay, and this is what you would more use in a civil case because getting somebody to pay somebody money isn't gonna like end their life. Right? So, and this one, the 0.05 is our good old middle of the road. And if you're not given alpha in a problem, you will use this as a conservative estimate. So use if not given alpha. This is going to be for the rest of the year. If you're doing a hypothesis test and alpha is not stated, we use 0.05 as the middle of the road. As a matter of fact, have I not told you to use 5% threshold all year? Yeah. So that just continues with what we've been doing. It's just a nice threshold in the middle. Okay. All right, go ahead and do your arts and crafts. It's weird because the camera's like sitting on the edge of the notebook and it keeps like rocking back. I was trying to fix it. Are you done with the alphas, honey? Okay. Okay, so part A here is a review from last Friday. We're going to state our hypotheses and define the parameter. I want you guys to know a couple of things. First, we need to decide if this particular problem is about proportions or mean. This one is about proportions. Okay. All right. That means that your parameter is P. And the letter that you're going to use in all three of these statements is P. On the AP Classroom MCQs, when you do them in a few weeks, they're going to try to trick you into putting P hat there. But remember, you're estimating the parameter. You don't need to estimate P hat. You have that. Okay. Fast food restaurant manager wants to reduce the proportion of customers who wait longer than 2 minutes to receive their food. According to store records, the proportion of customers with a long wait time is 0.63. Okay, So if nothing is going on, nothing's changed, no statement of change, the null hypothesis is that it's 0.63. Okay, but he wants to reduce. Reduce is less than. Okay, and then P equals the true proportion of, okay, where would I start copying off the problem? Customers. Yep, great job. Okay, that was a review from Friday. Okay, now I'm gonna flip my notebook over when you guys are ready. Guys all set? Okay. Okay, now for this, I'm gonna use my last year's notebook to help us. Um, because I like to do some weird movement. You can just, choose not to do this later, but it really does help people. And so type 2 error is fail to reject, right? Okay, so type 1 error means that you reject. Okay, so we're gonna start with our sentence that we wrote a minute ago. The sample obtained led him to believe, him being the restaurant manager, okay. Now, type 1 error means that you rejected the hoe when you shouldn't have. What I like to do is, I know it's silly, but I really like to reject the hoe like this. Means make the hoe go away. Cover it up. It's gone. Yeah. Okay, so I rejected it. I've rejected it. So it led him to believe that the true proportion was less than 0.63. Mm-mm. But we are gonna practice that at the end of this. We're going back to Fridays, practicing the sentences. Okay. Now, type two, leave two blanks here, by the way. We're gonna come back to the consequences. Type two is fail to reject. Okay, if I fail to reject the hoe, that means the hop goes away. So I'm gonna cover up the hop. Okay, so what should I say? The sample led him to believe, the sample obtained led him to believe that the true proportion is equal, yep, to 0.63 when it is actually less. Okay, after you're done writing your sentence, I want you to take your statistics hat off and put your business owner hat on. Okay, so you're now the restaurant manager. We have some people who work in restaurants in here. Okay. Several, actually. That doesn't mean you're the manager, but let's just pretend you are the manager. What would be a consequence of the type one error? It's not a statistics question, it's just a common sense life question. Yeah, so he thinks that customers are getting served quickly, but they're actually not, and they're probably getting that, right?
Yeah.
Okay, now what about type two? Customers are actually getting served faster than he thinks. Okay, which one of these is a more serious problem?
At least try.
The first one, okay,
I would be.
not necessarily, it depends on the, yeah. But yes, I don't want you to tell you that to think it always is, but most of the time. Okay, anyway, so How is your writing alpha going? Some of mine are pretty good, some of them aren't. Okay, now before we move on, we decided that type one was more serious. So now look back at the three different types. And should they be using alpha equals 0.10?
Yeah, I think they're like that.
Okay, so with alpha equals 0.10, the probability of type one happening is the highest. If type one is the more serious one, we want to make that the lowest. So they should use a lower alpha than 0.10.
They should be, think you're saying they should be, you know, at the table.
Yeah. Yeah. Besides, it'll give you another chance to write alpha. Guys, now, this says, the manager assigns an additional political order to collect random sample of 258 times and finds that P hat equals 0.576. Ooh, that's lower. With a P value of 0.0385. Interpret the P value in context and write their conclusion. Okay. Can you guys find in your notes from Friday? Sorry, your notes from Friday. In your notes from Friday, B and C of the example. Define the example, B and C. You understand what I'm saying? The battery thing, that I put light bulb, because I was running out of battery. Okay, I want you guys to work in your group. You're gonna write the p-value interpretation sentence first. And then you're gonna write the conclusions. You're gonna do part B and part C for this context, switch the context and numbers and things around. Work together, talk to each other. Write both sentences, and I'm gonna put up the correct answer in a minute. It starts with the word assuming. Okay, so I'm not done, but I am done with the first one. If you want to check your first one, mine is done. I, yeah. We're still using point 10.
Are we talking about?
Is that what you were asking?
Yeah.
Even though they should have used one smaller, we're still going with point 10. You guys have any questions about the first sentence up there? How did we do?
I am.
You did?
I think that we do, it's not, I did.
You guys sure you're good with the first one?
I believe Luke.
I believe Luke too. Okay, here's the second one when you're ready. Yes, it's always fill out the HA. It's either you have convincing evidence for the HA or you do not have convincing evidence for the HA. But it's always the HA, because that's kind of what you're trying to show. Does that make sense? Nope. Um. Does the logic of this make sense? I know it's still new, but like you're saying, there's only a 4% chance that that could have happened by chance. Such a small percentage, that means that probably the wait times did go down, which is good. Which means that the guy did the right thing by putting a new person into the whatever, billing orders. I just assumed they were in the drive-through. I don't know why. I don't know if that's like bias. I just saw like another person with a headset. But I think that's because that's what I did for my first job. I was in the drive-through at McDonald's because the owner of that particular McDonald's is sexist. And you never let any of the boys work any of the counter or the drive-through. Terrible. It was really awful. I mean, I didn't want to let the food. But it's just doesn't seem right.
Hungry.